Hi everyone, my name is Mar, and today I'm going to introduce you to critical thinking and research. We will cover three main topics: the different types of research, how research is structured, and how you can apply critical thinking when working on your research projects this semester. What is critical thinking? Critical thinking is about looking at information carefully rather than just accepting it at face value. This is really important because not all information is equally reliable, so you have to analyze it and question it. Instead of asking, "What does this article say?" a critical thinker would ask, "Who wrote this? What evidence are they using? Is there anything missing or biased?" Be critical and open-minded because you're not learning information, you're evaluating it. Read multiple existing studies, compare them, and notice any inconsistencies. This is the mind of a researcher. There are three main types of research that we're going to discuss today. First, qualitative research, which focuses on understanding experiences and opinions. Second, quantitative research, which focuses on numbers and measurable data. And third, mixed methods research, which combines both approaches to get a more complete understanding of a topic. It is important to note that each type of research has its own strengths and weaknesses, and it is the researcher's job to choose which type is most appropriate for their study. Qualitative research is used when something can't be easily measured with numbers. Instead of focusing on data, it focuses on meaning, experiences, and deeper understanding. Usually, it involves a smaller group of participants, but it goes much more in depth. For example, if you wanted to understand how students feel about online learning, you wouldn't just give them a multiple choice survey. You talk to them, ask open-ended questions, and explore their perspectives. So, qualitative research is really about quality over quantity. There are a few common methods used in qualitative research. You have one-on-one interviews, which usually involves asking open-ended questions to get detailed responses from a single person. There are focus groups, which are group discussions where researchers observe how people share and respond to different opinions. There's ethnographic research, which involves spending time in a specific environment and observing the behavior of participants over a longer period of time. And lastly, qualitative observation is when researchers just observe people from a distance without directly interacting or interfering with them. Quantitative research is sort of the opposite in the sense that it focuses more on numbers and measurable data. Researchers collect data that can be analyzed using statistics, graphs, or mathematical tools. For example, imagine you're growing three separate plants with different amounts of water, and then you measure their height over a span of 2 weeks. You're collecting numerical data and comparing results. You're not going to ask the plant how it feels to grow tall or simply observe it in its natural environment. You're measuring and comparing the numerical data between many subjects. This research type helps us document and discover patterns. Another important discussion is between primary and secondary research. Primary research is when you collect your own data, like conducting an experiment or a survey or an interview, versus secondary research, which is when you analyze data that already exists, like reading studies or doing a literature review. Most research uses a mix of both. For example, you might read existing studies first to understand a topic, and then conduct your own research to build on that knowledge. Observational versus experimental. Observational studies is exactly what it sounds like. It's just watching and recording behavior without interfering. Experimental studies go a step further. They include manipulating variables to see cause and effect relationships. For example, if we go back to the plant example, we manipulate how much water we give each plant to see how it impacts their growth in a 2-week time span. That's experimental. So, experimental research sort of helps us understand why something happens. Theory versus hypothesis. Theory and hypothesis are two terms that are often confused and mixed up, and I don't blame you. So, while they are related, they're not the same thing, and it is important that you understand the difference while you start your projects. What is a theory? A theory is an explanation that has been tested over and over and over again and proven by a large amount of evidence. It's not just a guess, it's built over time through a lot of testing, evidence, and observation. A good example is the germ theory of disease. This theory explains that diseases are caused by microorganisms like bacteria and viruses. But through years of research and observation, scientists discovered that these tiny organisms can be transmitted through contact, air, or surfaces. Because of this theory, we've adopted life changing practices like washing our hands, sterilizing equipment, receiving vaccines, and using antibiotics. So, a theory helps explain why something happens and also helps predict and prevent future problems. What is a hypothesis? A hypothesis is a specific, testable prediction. It is sometimes written as an if then statement, especially for your age, but that's not always the best method to look for a hypothesis. An example of using an if then statement would be if hand washing reduces infections, then hospitals that enforce strict hygiene will have fewer cases. Unlike theories, hypotheses haven't been proven yet. They're what researchers test through experiences. Also, a hypothesis has to be falsifiable, meaning it can be proven wrong. That's important because it allows research to be objective and based on evidence, not assumptions.
Hi everyone, my name is Devin. Now that we've covered the different types of research, let's move into how a research study is actually structured. Understanding the structure is really important because it helps us break down studies more effectively and evaluate their overall strength and reliability. We'll start with the literature review. This section provides background information on the topic or article you're reading. It usually includes a summary of past research to explain what is already known or what has previously been studied. It also identifies gaps in knowledge, meaning what is still unknown or controversial. Finally, it introduces the research question and hypothesis of the study. When reading a literature review, it's important to focus on what is already known and what the study is trying to discover. Next is the methodology section. This explains how the study was conducted so that others can replicate its findings. It includes such details as the design of the study, the participants involved, the variables being tested, the procedures used, and ethical considerations, like informed consent. The main goal of this section is transparency, making sure other researchers can repeat the study and see if they can get similar results. Next, we have the results and data analysis section. This part presents the data before any interpretations are made. You will typically see tables, graphs, statistical tests that show trends or patterns in the data, as well as any significant differences. For example, a study might show that a treatment group had a 30% lower infection rate than the control group. It is important to remember that this section only presents the data and is not there to explain or interpret any of the results. Lastly, we have the discussion and conclusion section. This is where researchers interpret the results and connect them back into existing research. The study will answer questions such as what the results mean, whether the findings were as expected, what the strengths and limitations are, and what future research should be done. This section essentially explains the why behind the results and highlights the key takeaways we should focus on. Now we move into evaluating research, specifically determining how strong a study is. Not all studies are equal, so it's important to understand which types of research provide more reliable evidence. Meta-analysis and randomized control trials are considered stronger than observational studies. Meta-analysis combine results from multiple studies, which help reduce bias. Randomized control trials are random assignments, which also reduce bias and confounding variables. The main goal is to minimize bias as much as possible to produce reliable results. Additionally, larger sample sizes and stronger methodologies increase reliability. For example, a study with 10,000 participants is generally more reliable than one with only 10. Next is questioning assumptions. Every study is based on certain ideas or assumptions, and it's important to challenge them to ensure that the research is objective. Instead of simply accepting the results, we should ask questions like, why was the study done? Who funded it? And what factors could be influencing the results? For example, if a soda company funds research on sugar, there may be bias in how the results are presented. One of the biggest mistakes in research is confusing correlation with causation. Correlation means that two things are related, but one does not necessarily cause the other. Causation means that one variable directly causes a change in another. For example, ice cream sales and shark attacks both increase during the summer, but ice cream does not cause shark attacks. The real factor is hot weather, which increases both. This shows that just because two things happen together does not mean one caused the other. Now we move into how research is actually applied in real life. When doing research, it's important to use credible sources. Good starting points include Google Scholar, PubMed, and academic journals. You should also check whether the source is peer-reviewed. Look at the author's credentials, and consider how often this study is cited. Generally, the more citations and the more reputable the publisher, the more reliable the source is. Research is used in real-world situations all the time. It plays a role in areas such as policy design, market research, and product development. A strong example is public health campaigns, where research is used to reduce smoking rates by studying behavior and effective interventions. This shows that research isn't just theoretical, it actually influences real-world decisions. There are several common mistakes people make when interpreting results. These include overgeneralization, confusing correlation with causation, cherry-picking data, and ignoring opposing viewpoints. To avoid these mistakes, we should look at multiple studies, consider limitations, and analyze opposing evidence. Doing this helps us develop a more balanced and accurate understanding of the research. Thank you for listening. We hope this workshop has helped you better understand critical thinking and research. If you have any questions, feel free to ask. To stay connected with us, follow our Instagram and website for updates and information.